Today we're talking about factoring rational expressions, and we're going to multiply these two things together. So first what we're going to do is factor each set of parentheses here. And so we're going to look at the top of this, and we're going to pull out a 6x that is in common, and that is going to leave me with a 2x minus 1. Now the bottom of that fraction can't be factored at all, so I'm just going to write it down as an x plus 6. When we look at the top of the second fraction, we're going to factor that out, and we're going to be able to pull a 6 out of 30 and of 18. And so when I pull a 6 out, that'll leave me with a 5x plus 3. Now so far we're not able to cancel anything, and what I'm hoping is going to happen is that this bottom quadratic equation right here is going to factor into something that'll cancel out with either of the things on the top. So I'm going to take it, I'm going to multiply 10 times negative 3, and 10 times negative 3 is a negative 30. I'll need to find two numbers that multiply to the negative 30 that will add to the positive 1 on the inside, and that would be 5 and 6, and I have to pick one to be negative. In this case we're going to pick 5 to be negative, so they'll add to a positive 1. So I'm going to rewrite this problem. Instead of 10x squared plus x minus 3, I'm going to write it as 10x squared minus 5x plus 6x minus 3, considering that would be equal to this, because negative 5 and positive 6 make that 1 in there. Now I'm going to factor it by grouping. I'm going to look at each group and say that the first set of parentheses I could be able to pull out a 5x, and the second set of parentheses I'd be able to pull out a 3. So this is going to leave me with 5x plus 3, and when I pull out a 5x from the first set of parentheses, that's going to leave me with a 2x minus 1. And it'll be the same thing in the second group of parentheses. That would be a 2x minus 1 as well. So a fully factored version of the bottom of this would be 5x plus 3 times 2x minus 1. Now what we're hoping to happen here is that it'll cancel with something on the top. And if I look at the other stuff in red, you can see that I have a 5x plus 3 on the top of the second fraction, which will cancel with the 5x plus 3 on the bottom. And I have a 2x minus 1 on the top of the first fraction, which will cancel with the 2x minus 1 on the bottom of the second. Now that'll leave me with several things left over, which would be the final answer. I'll multiply 6x times 6 to get 36x over top of, and this x plus 6, nothing happened to it, it just sort of stays down here. And this is the simplified version of the multiplication problem. Now what we want to do is also talk about factoring or dividing these expressions, and you can see here I have two very large fractions that I will need to divide and simplify and everything. And so I want to factor everything again. And some of them are easy to factor and some of them are kind of hard to factor. But basically what I'm going to end up doing is turning this into a multiplication problem. In order to do that, I need to flip the second fraction upside down, and I'm going to go ahead and factor it as I do it. If you look at the first, the top here, which will become my new bottom, I can pull a negative 1 out, which will then leave me with a negative 8 plus 5r, or I could say 5r minus 8. I like to switch the order around so that the r's are leading, and it just makes it easier a little bit later. The second set of parentheses, that's the stuff that's on the bottom right here, I'd be able to pull out a 4r squared. And that's going to become the top of my new fraction, 4r squared, and that'll leave me with an r minus 6. Now nothing cancels yet. I could simplify the positive 4 over the negative 1, but we're just going to go ahead and look at the second fraction, the first fraction in this case, and we're going to factor out the bottom of there. We have an 8r squared cubed minus 16r squared, so I'd be able to pull out an 8r squared, which will leave me with a r minus 2. Now I need to factor the top of the second fraction, and you can see that if I just look at it, that all the things in that have a 2 in common, but not just a 2, but a negative 2. And if I pull a negative 2 out of there, that'll leave me with a positive 5r squared, a negative 18r, and a positive 16. Now that is still factorable. I'll take care of that in a second, but we could go ahead and cancel a few things out if we wanted to. For instance, if we said the negative 2 times a positive 4r squared, that is a negative 8r squared on the top, and I have an 8r squared and a negative 1 on the bottom, which that will cancel with. So that could simplify my life a little bit. I have just a little bit of canceling. I do need to still factor the green stuff in the middle here. So what I'm going to do is multiply 5 times 16, and that's going to be 80. and two numbers to multiply to 80 that add to the negative 18 in the middle are going to be negative 10 and 8. So the top of this is going to be 5r squared, negative 10r, negative 8r, and positive 16. And I can factor that by grouping. So the top of this fraction is going to then be 5, from the first set of parentheses, a 5r can come out, leaving me with a r minus 2. And from the second set of parentheses, a negative 8 can come out, which again will leave me with the r minus 2. Now that's the top of the first fraction. We've already gotten rid of the negative 2 that was out in front. The bottom of the first fraction is only this r minus 2, which will then cancel. And then we have the second fraction stuff, and that is the r minus 6, which doesn't cancel with anything yet. And then the 5r minus 8, which will cancel with the 5r minus 8 from the first fraction. So all of this stuff, all this thing that we had happen with the division and everything will end up canceling except for the r minus 6. And that is the final answer to this problem.